Welcome to Azure AD Connect. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Azure AD Connect is Microsoft's solution for bridging the gap between on-premises Active Directory environments and the cloud-based Azure Active Directory service. In today's hybrid IT landscape, organizations need to maintain identity consistency across both traditional data centers and cloud platforms. Azure AD Connect serves as the synchronization engine that makes this possible by establishing a reliable connection between these two identity systems. The fundamental purpose of Azure AD Connect is to enable users to authenticate and access resources using a single identity, regardless of whether those resources are hosted on-premises or in the cloud. This unified identity approach eliminates the need for users to remember multiple credentials and reduces the administrative overhead of managing separate identity systems. Organizations can leverage their existing on-premises Active Directory infrastructure while taking advantage of cloud services like Office 365, Dynamics 365, and thousands of SaaS applications integrated with Azure AD. Azure AD Connect synchronizes objects such as user accounts, groups, and contacts from your on-premises directories to Azure AD. This synchronization can happen in multiple ways, offering flexibility based on organizational requirements. The tool supports password hash synchronization, pass-through authentication, and federation with Active Directory federation services. Each authentication method provides different levels of security, administrative control, and user experience, allowing organizations to choose the approach that best fits their security policies and compliance requirements. Core Components Architecture. Understanding the architecture of Azure AD Connect requires examining its core components and how they interact. The system consists of several essential elements that work together to establish and maintain synchronization between on-premises Active Directory and Azure Active Directory. At the heart of this architecture is the Azure AD Connect synchronization engine, which runs on a Windows server within your on-premises environment. The synchronization engine is responsible for reading identity data from your on-premises Active Directory domain services and writing that information to Azure Active Directory in the cloud. This engine operates based on synchronization rules that determine which objects should be synchronized and how attributes should be transformed during the synchronization process. These rules can be customized to meet specific organizational requirements, though Microsoft recommends using the default rules whenever possible to simplify troubleshooting and support. The Metaverse component acts as an intermediate staging area within the synchronization engine. When objects are read from on-premises Active Directory, they are first projected into the metaverse where they can be merged, filtered, and transformed according to synchronization rules. The metaverse provides a unified view of identity objects from all connected data sources, making it possible to correlate identities across multiple directories if needed. This is particularly useful in organizations that have acquired other companies and need to consolidate multiple Active Directory forests. Azure AD Connect also includes connectors that interface with both the on-premises Active Directory and Azure Active Directory. The Active Directory connector reads objects and attributes from domain controllers using LDAP queries, while the Azure AD connector writes the synchronized data to Azure AD using the Microsoft Graph API. These connectors handle the actual communication protocols and ensure that data is transferred securely and reliably. The connector space stores a replica of the data from each connected directory, allowing the synchronization engine to track changes and determine what needs to be synchronized during each cycle. Authentication Methods Overview. Azure AD Connect supports three primary authentication methods, each with distinct characteristics, security implications, and use cases. Choosing the right authentication method is a critical decision that affects user experience, security posture, and administrative requirements. Organizations should carefully evaluate their security policies, compliance needs, and existing infrastructure before selecting an authentication approach. Password hash synchronization is the simplest and most commonly used authentication method. In this approach, Azure AD Connect synchronizes a hash of user passwords from on-premises Active Directory to Azure Active Directory. The important security consideration here is that the actual password is never sent to the cloud. Instead, what gets synchronized is a cryptographic hash derived from the NTLM hash stored in Active Directory. When a user authenticates to Azure AD, the service computes a hash of the entered password and compares it with the synchronized hash. This method provides the best user experience because authentication happens directly in the cloud without any dependency on on-premises infrastructure. Pass-through authentication takes a different approach by validating passwords directly against on-premises Active Directory in real time. When a user attempts to sign into Azure AD, the authentication request is passed through to one or more on-premises authentication agents running in your data center. These agents validate the credentials against Active Directory and return the result to Azure AD. The key advantage of this method is that passwords, even in hashed form, never leave the on-premises environment. This approach appeals to organizations with strict compliance requirements that prohibit storing any form of credentials in the cloud. However, it does require maintaining high availability of the authentication agents and network connectivity between Azure and the on-premises environment. Federation with Active Directory Federation services represents the most complex, but also most flexible authentication option. In a federated setup, authentication is delegated entirely to your on-premises ADFS infrastructure. When users attempt to access cloud resources, they are redirected to the on-premises Federation server, which handles authentication and issues security tokens that Azure AD trusts. This method provides maximum control over the authentication process, allowing implementation of multi-factor authentication, smart card authentication, third-party MFA solutions, and complex access policies. Federation is typically chosen by organizations that require advanced authentication scenarios or have regulatory requirements that mandate on-premises authentication control. The trade-off is increased infrastructure complexity and operational overhead. Password hash synchronization deep dive. Password hash synchronization deserves detailed examination as it is the most widely deployed authentication method with Azure AD Connect. Understanding how it works, its security model, and its operational characteristics is essential for implementing and managing hybrid identity environments. The process begins with Azure AD Connect reading the password hash from the on-premises Active Directory database during each synchronization cycle. The security architecture of password hash synchronization is built on multiple layers of cryptographic protection. On-premises Active Directory stores passwords using the NTLM hash algorithm, which is a one-way cryptographic function. Azure AD Connect takes this NTLM hash and applies additional cryptographic transformations using SHA-256 with a salt value, creating what is effectively a hash of a hash. This derived hash is what gets transmitted to Azure Active Directory over an encrypted HTTPS connection. Even if this hash were somehow intercepted or compromised, it cannot be used to authenticate to on-premises Active Directory because it is not the same as the original NTLM hash. The synchronization frequency for password hashes is approximately every 2 minutes by default. This means that when a user changes their password in the on-premises environment, there is a brief window before that change is reflected in Azure AD. During this period, the user would need to use their old password to authenticate to cloud services. Organizations can configure the synchronization schedule, though more frequent synchronization requires more processing resources. For immediate password updates, Azure AD Connect provides a password write-back feature when using Azure AD Premium licensing, allowing password changes initiated in the cloud to be written back to on-premises Active Directory instantly. One significant advantage of password hash synchronization is its support for leaked credential detection. Azure AD maintains a database of compromised credentials discovered from various security breaches and dark web monitoring. When password hash synchronization is enabled, Azure AD can check synchronized password hashes against this database and alert administrators when users are using compromised credentials. This provides an additional layer of security that is not available with pass-through authentication or federation, where passwords never reach Azure AD for comparison. The leaked credential protection feature helps organizations proactively respond to credential compromise before attackers can exploit those credentials. Pass-through authentication implementation. Pass-through authentication provides a different architectural approach to hybrid authentication by keeping password validation entirely within the on-premises environment. This method appeals to organizations with regulatory or compliance requirements that prohibit any form of credential information from being stored in the cloud. Understanding the components and data flow of pass-through authentication is crucial for successful implementation and operation. The architecture consists of lightweight authentication agents that are installed on one or more on-premises servers. These agents establish outbound connections to Azure AD and register themselves as available to handle authentication requests for your tenant. When a user signs into an Azure AD integrated application, the authentication request is placed in a queue in Azure. The on-premises authentication agents continuously poll this queue looking for authentication requests. When an agent retrieves a request, it extracts the username and password, validates them against the local Active Directory domain controller, and returns the result to Azure AD. The entire process typically completes in less than a second. Security is maintained through several mechanisms. The authentication agents establish outbound HTTPS connections only, meaning no inbound firewall routes are required in your corporate network. This significantly reduces the attack surface compared to traditional solutions that require exposing authentication infrastructure to the Internet. The agents use certificate-based authentication to prove their identity to Azure AD, and all communication is encrypted using TLS passwords or encrypted in memory during validation and are never written to disk or logged. The agents also implement throttling and lockout policies to protect against brute force attacks. High availability is achieved by deploying multiple authentication agents. Microsoft recommends installing at least 3 agents for production environments to ensure continuity of authentication services during maintenance or unexpected outages. The agents operate in an active-active configuration, meaning all agents actively process authentication requests based on availability. If an agent is processing a request, other agents wait for the next available request. This provides both load distribution and redundancy. When deploying multiple agents, they should be installed on different servers to avoid single points of failure. The authentication agents are lightweight and can be installed on existing infrastructure such as domain controllers or member servers, though best practices suggest dedicated servers in high-volume environments. Federation with ADFS. Federation using Active Directory Federation services represents the most sophisticated authentication approach available with Azure AD Connect. Federation establishes a trust relationship between your on-premises identity infrastructure and Azure Active Directory, allowing your on-premises environment to maintain complete control over the authentication process. This method is particularly valuable for organizations with complex authentication requirements, regulatory constraints, or existing investments in Federation infrastructure. The Federation architecture relies on ADFS servers deployed in your on-premises environment, typically with web application proxy servers in a perimeter network to handle external authentication requests. When a user attempts to access an Azure AD integrated application, Azure AD redirects the user's browser to your Federation service. The ADFS server presents a login page, collects credentials, validates them against Active Directory, and issues a SAML security token if authentication succeeds. This token is then posted back to Azure AD, which validates the token's signature using the Federation Trust Certificate and grants access to the requested resource. The key point is that user credentials never reach Azure AD. They are validated entirely within your on-premises environment. Federation enables advanced authentication scenarios that are not possible with password hash synchronization or pass-through authentication. You can implement smart card authentication using PKI certificates stored on physical or virtual smart cards. Multi-factor authentication can be implemented using third-party solutions like RSA Secure ID, Duo Security, or custom authentication methods. Federation also supports claims-based access control, where authentication decisions can be based on group membership, device compliance state, network location, or any other attribute available in Active Directory. These capabilities make Federation the preferred choice for organizations in highly regulated industries such as healthcare, finance, or government where stringent authentication requirements exist. The operational complexity of Federation should not be underestimated. Active Directory Federation Services infrastructure requires careful planning, deployment, and ongoing maintenance. You need to deploy multiple Active Directory Federation Services servers for high availability, configure web application proxy servers for external access, obtain and manage secure sockets layer certificates, and maintain the health of all these components. Active Directory Federation Services servers require regular patching and updates, and the Federation Trust certificates must be renewed before expiration. Monitoring is critical to detect and respond to issues quickly because any problem with the Federation infrastructure affects user access to cloud services. Despite this complexity, Federation provides maximum control and flexibility, making it the right choice for organizations that need those capabilities and have the resources to manage the infrastructure. Synchronization engine mechanics. The synchronization engine in Azure AD Connect operates on a sophisticated schedule that determines when objects and attributes are synchronized between on-premises Active Directory and Azure Active Directory. Understanding these mechanics is essential for troubleshooting synchronization issues and planning changes to your identity infrastructure. The engine runs multiple processes that work together to detect changes, apply transformations, and update target directories. The default synchronization cycle runs every 30 minutes. During each cycle, the engine performs several distinct operations. First, it executes an import operation against each connected directory, reading any objects that have changed since the last import. For Active Directory, this uses the USN changed attribute to efficiently identify modified objects without scanning the entire directory. The imported changes are stored in the connector space, which is a staging area that holds a replica of data from each connected directory. This staging approach allows the engine to work with a consistent snapshot of data even if the source directories continue to change during processing. After importing changes from all connected directories, the synchronization engine runs synchronization rules to project objects into the metaverse and determine what changes need to be applied to target directories. Synchronization rules are composed of scoping filters that determine which objects the rule applies to, join rules that correlate objects across directories, and transformation rules that map source attributes to target attributes. The engine evaluates all applicable synchronization rules in precedence order, with lower precedence numbers taking priority. Default synchronization rules use precedence values in the 100 to 500 range, allowing custom rules with lower precedence values to override default behavior when needed. Once the metaverse is updated with all changes, the engine performs export operations to write changes to target directories. For Azure Active Directory, objects and attribute changes are staged in the Azure AD connector space before being exported to the cloud. The export process respects the capabilities and constraints of each target directory. For example, certain attributes in Azure AD are read-only and cannot be set through synchronization, while others have specific format requirements. The export confirmation process validates that changes were successfully applied to the target directory and updates tracking information in the connector space. If an export operation fails due to a conflict or validation error, the synchronization engine logs the error and continues processing other objects, allowing administrators to investigate and resolve issues without blocking all synchronization. Object filtering and scoping. Not every object in your on-premises Active Directory should be synchronized to Azure Active Directory. Effective use of Azure AD Connect requires implementing appropriate filtering to control which users, groups, and other objects are included in synchronization. Filtering reduces clutter in your cloud directory, improves synchronization performance, and helps maintain security by preventing unnecessary accounts from being created in Azure AD. Azure AD Connect provides several filtering mechanisms that can be used individually or in combination. Domain-based filtering allows you to select which Active Directory domains and organizational units should be included in synchronization. This is configured during initial setup but can be modified later using the Azure AD Connect wizard. Organizational unit filtering is particularly useful in large environments where different OUs serve different purposes. For example, you might synchronize user accounts from an OU containing active employees while excluding OUs that contain service accounts, test accounts, or disabled user accounts. Attribute-based filtering provides more granular control by using object attributes to determine synchronization eligibility. A common approach is creating a custom attribute or repurposing an existing attribute like extension attribute 1 to act as a synchronization flag. You can then configure filtering rules to only synchronize objects where this attribute contains a specific value. This method is flexible because you can control synchronization at the individual object level without restructuring your Active Directory OU hierarchy. The filtering logic can include complex conditions using multiple attributes and logical operators, though simpler rules are generally easier to maintain and troubleshoot. Group-based filtering is another powerful technique where you define an Active Directory group and configure Azure AD Connect to synchronize only members of that group. This approach is intuitive for administrators because managing synchronization becomes a matter of group membership management, a familiar task in Active Directory environments. However, group-based filtering should be used cautiously in large environments because the synchronization engine must resolve group membership for all objects during each cycle, which can impact performance. Group-based filtering is best suited for smaller deployments or specific scenarios where the benefits of simplified management outweigh the performance considerations. Regardless of which filtering method you choose, it is critical to thoroughly test your filtering rules in a non-production environment before implementing them in production to avoid accidentally excluding important objects from synchronization. Attribute mapping and transformation. Attribute mapping defines how attributes from on-premises Active Directory are synchronized to corresponding attributes in Azure Active Directory. Understanding attribute flows and transformation rules is crucial for ensuring that synchronized objects contain the correct information and meet the requirements of cloud applications. Azure AD Connect includes default attribute mappings that work for most organizations, but many scenarios require custom transformations to address unique business requirements. The synchronization engine uses attribute flow rules to control how data moves between directories. Direct flows simply copy an attribute value from source to destination without modification. Constant flows set a target attribute to a specific value regardless of the source attribute value. This is useful for setting default values or flags that differentiate synchronized objects. Expression flows apply transformations using a declarative expression language that supports string manipulation, conditional logic, and mathematical operations. For example, you might use an expression to construct a user's display name by concatenating first name, middle initial, and last name with proper formatting and spacing. Some attributes require careful consideration due to their importance in Azure AD. The user principal name attribute serves as the primary username for authentication and must be a unique, routable email address format. Many organizations synchronize the on-premises UPN directly, but this only works if your on-premises UPN suffix matches a verified domain in Azure AD. If there is a mismatch, you need to implement a transformation rule to construct a valid UPN using a verified domain suffix. The proxy addresses attribute contains email addresses and aliases for the user and must follow specific formatting rules, with each address prefixed by its type, such as SMTP for primary email or SMTP for secondary addresses. The source anchor attribute deserves special attention because it establishes the immutable identifier that links an on-premises object to its Azure AD counterpart. By default, Azure AD Connect uses the object GUID attribute from Active Directory as the source anchor. This choice provides stability because object GUID never changes throughout an object's lifetime, even if the object is moved, renamed, or has other attributes modified. The source anchor selection is made during initial Azure AD Connect installation and cannot be changed later without completely removing and recreating all synchronized objects in Azure AD. Therefore, it is critical to select the appropriate source anchor attribute during deployment planning. Organizations with multiple Active Directory forests might need to use a different attribute like ms-ds-consistency GUID to ensure uniqueness across forests. Installation prerequisites and planning. Successful deployment of Azure AD Connect begins with thorough planning and ensuring all prerequisites are met. The installation process itself is straightforward, but the decisions made during planning have long-term implications for performance, security, and manageability. Taking time to properly assess your environment and requirements before installation prevents issues and reduces the need for complex reconfiguration later. The server that will host Azure AD Connect must meet specific hardware and software requirements. Microsoft recommends a dedicated server with at least 4 CPU cores and 8 GB of RAM, though the exact requirements scale with the number of objects being synchronized. For environments with fewer than 10,000 objects, a smaller server may suffice, while organizations synchronizing over 100,000 objects should consider more powerful hardware and potentially a SQL Server database instead of the default SQL Server Express. The server must run Windows Server 2016 or later with the latest updates applied. Installing Azure AD Connect on a domain controller is technically supported but not recommended for security and performance reasons. A dedicated member server provides better isolation and allows for easier troubleshooting. Network connectivity requirements include reliable connection to both on-premises Active Directory domain controllers and the Internet for communication with Azure AD. The Azure AD Connect server needs HTTPS outbound access to several Microsoft endpoints for synchronization, authentication, and telemetry. Proxy servers can be used if direct Internet access is not available, and the installation wizard can configure proxy settings during setup. Firewall rules should allow outbound HTTPS traffic on port 443 to Azure endpoints, and internal firewall rules should permit LDAP and secure LDAP connectivity to domain controllers. For pass-through authentication deployments, the authentication agents also require similar outbound connectivity. Permissions in both on-premises Active Directory and Azure Active Directory must be carefully configured. The account used to run Azure AD Connect synchronization service requires specific read permissions in Active Directory to query objects and attributes. By default, the installation wizard creates an account with appropriate permissions, but some organizations prefer to use a pre-created account with explicitly defined permissions for better control and documentation. In Azure AD, you need global administrator credentials during initial installation to configure synchronization and create the necessary service account. After installation, day-to-day synchronization runs with more limited permissions, but administrative tasks like modifying synchronization rules or changing authentication methods require elevated privileges. Planning these permission requirements in advance and coordinating with Active Directory and Azure AD administrators ensures a smooth installation process and proper ongoing operation of the synchronization service. Express versus custom installation. Azure AD Connect provides two installation modes that cater to different organizational needs and complexity levels. Understanding the differences between Express and custom installation is crucial for selecting the appropriate deployment approach. Express installation is designed for straightforward scenarios where default settings meet organizational requirements, while custom installation provides granular control over every aspect of the configuration. Express installation is the fastest path to getting Azure AD Connect operational. This mode assumes a single Active Directory forest, uses password hash synchronization as the authentication method, and synchronizes all domains and organizational units within the forest. The installation wizard automatically creates the required service account in Active Directory with appropriate permissions, configures the synchronization schedule, and starts the initial synchronization immediately after installation completes. Express installation is ideal for organizations with straightforward identity requirements, typically those with fewer than 100,000 objects and a single forest topology. Custom installation unlocks advanced configuration options that address complex scenarios. During custom installation, you can select pass-through authentication or federation instead of password hash synchronization. You can configure group-based filtering to synchronize only specific users and groups rather than the entire directory. Custom installation allows you to specify a custom source anchor attribute instead of using the default object GUID, which is necessary in multi-forest environments where object GUID might not provide unique values across forests. You can also configure staging mode, which installs Azure AD Connect but prevents it from exporting changes to Azure AD, useful for testing configurations or implementing disaster recovery solutions. The installation mode you choose has implications beyond initial setup. Express installations can be converted to custom mode later using the Azure AD Connect wizard's customization options, but certain fundamental choices like the source anchor attribute cannot be changed after initial synchronization. Organizations should carefully assess their requirements during planning to determine if custom installation is necessary. Factors to consider include the number of forests, authentication requirements, filtering needs, and whether the environment might require advanced features like device write-back, password write-back, or group write-back in the future. Starting with custom installation provides flexibility to enable these features without reconfiguration. Monitoring and health verification. Effective monitoring of Azure AD Connect is essential for maintaining reliable hybrid identity operations. Without proper monitoring, synchronization failures, authentication issues, or configuration problems might go undetected until users report access problems. Microsoft provides several tools and mechanisms for monitoring Azure AD Connect Health, synchronization status, and overall hybrid identity infrastructure. Implementing comprehensive monitoring enables proactive identification and resolution of issues before they impact users. Azure AD Connect Health is a cloud-based monitoring service that provides real-time visibility into the health and performance of your hybrid identity infrastructure. After installing the Azure AD Connect Health agent on your Azure AD Connect server and any ADFS or domain controller servers, the agent collects performance metrics, synchronization statistics, and error information, uploading this data to Azure AD where it can be analyzed and visualized. The Azure AD Connect Health portal provides dashboards showing synchronization errors, duplicate attribute conflicts, authentication failures, and performance metrics. Alert notifications can be configured to notify administrators via email when critical issues are detected, such as synchronization failures or high authentication error rates. The Synchronization Service Manager application installed with Azure AD Connect provides detailed operational information about synchronization runs. The Operations tab displays a chronological list of all synchronization cycles, showing the start time, duration, and statistics for each run including objects added, updated, and deleted. When synchronization errors occur, the Operations tab shows error details that can be expanded to view the specific object and attribute causing the problem. This granular information is invaluable for troubleshooting synchronization issues. The Connectors tab displays configuration information for each connector and allows you to run manual synchronization operations for testing or immediate synchronization needs. PowerShell provides programmatic access to Azure AD Connect monitoring data, enabling automation of health checks and integration with existing monitoring systems. The AD Sync module includes commandlets like get AD Sync scheduler to view synchronization schedule configuration, start AD Sync cycle to manually trigger synchronization, and get AD Sync CS object to query objects in connector spaces. Organizations can create custom PowerShell scripts that check synchronization status, query for errors, and export metrics to monitoring platforms like Azure Monitor, System Center Operations Manager, or third-party solutions. This programmatic approach enables building comprehensive monitoring dashboards that provide unified visibility across all IT infrastructure components, not just Azure AD Connect. Troubleshooting synchronization errors. Synchronization errors are among the most common issues encountered with Azure AD Connect. These errors occur when the synchronization engine cannot successfully create, update, or delete an object in Azure Active Directory due to conflicts, validation failures, or other constraints. Understanding the types of synchronization errors, their causes, and resolution approaches is crucial for maintaining healthy hybrid identity operations. Duplicate attribute errors are one of the most frequent synchronization problems. These occur when attempting to synchronize an object whose attributes conflict with an existing object in Azure AD. The most common duplicate attribute errors involve user principal name and proxy addresses attributes, which must be unique across all users in the Azure AD tenant. For example, if two on-premises user accounts have the same email address in their proxy addresses attribute, only the first object to synchronize succeeds while the second encounters a duplicate attribute error. Resolution requires identifying the conflicting objects, determining which should have the attribute value, and updating or removing the attribute from the other object. Invalid attribute errors occur when an attribute value does not meet Azure AD's validation requirements. Common examples include user principal name values that do not match verified domain suffixes, proxy addresses that are improperly formatted, or attribute values exceeding maximum length limits. The synchronization error details typically indicate which attribute failed validation and provide information about the validation rule that was violated. Resolving these errors requires correcting the attribute values in on-premises Active Directory and allowing the next synchronization cycle to propagate the corrected values. In some cases, transformation rules may need to be modified to ensure attributes are formatted correctly before being exported to Azure AD. Object conflicts and hard matching failures represent more complex error scenarios. When Azure AD Connect attempts to create a new user in Azure AD, it first checks if an object with the same immutable ID already exists. If a match is found, the synchronization engine links the on-premises object to the existing cloud object rather than creating a duplicate. However, if the existing cloud object has attributes that conflict with the on-premises object, synchronization errors can occur. Hard matching relies on specific attributes like user principal name or proxy addresses to match objects when immutable IDs do not align. Troubleshooting these scenarios often requires examining object history in both directories, understanding how objects were originally created, and potentially using PowerShell to manually resolve the linkage between objects. The complexity of these errors underscores the importance of proper planning and initial configuration to avoid object mismatches. Password write-back configuration. Password write-back is a premium feature available with Azure AD Premium licensing that enables passwords changed or reset in Azure Active Directory to be written back to on-premises Active Directory. This capability provides a seamless self-service password reset experience where users can reset their passwords through the Azure AD portal or Office 365, and those changes are immediately reflected in the on-premises environment. Password write-back eliminates the synchronization delay inherent in password hash synchronization and enables true bidirectional password management. The architecture of password write-back involves secure communication channels between Azure AD and the on-premises Azure AD Connect server. When a user initiates a password reset in Azure AD, the new password is encrypted using a public key certificate before being transmitted. The encrypted password is placed in a service bus queue specific to your tenant. The Azure AD Connect server, running the password write-back service component, retrieves the encrypted password from the queue, decrypts it using the corresponding private key, and writes the new password to on-premises Active Directory using appropriate APIs. This entire process typically completes within a few seconds, providing near instantaneous password updates. Security considerations are paramount when implementing password write-back. The on-premises service account used by Azure AD Connect requires specific permissions in Active Directory to change user passwords. These permissions should be carefully controlled and audited. The encryption and decryption of passwords during transit ensures that sensitive credential information is protected even if network traffic were intercepted. However, organizations must ensure that the certificate used for encryption is properly secured and that its private key is protected. Regular certificate rotation according to security policies is recommended, though this must be carefully coordinated to avoid service interruptions. Enabling password write-back involves multiple configuration steps. First, the feature must be enabled in Azure AD Connect using the Optional Features section of the installation wizard. This installs the password write-back service component and configures the necessary synchronization rules. Second, Azure AD Self-Service Password Reset must be configured with write-back enabled in the Azure portal. This includes defining password reset policies, authentication methods required for password reset, and notification settings. Third, permissions must be verified to ensure the Azure AD Connect service account has the required rights in Active Directory. After enabling password write-back, thorough testing should be performed to verify that password changes flow correctly in both directions and that all security controls are functioning as expected. Organizations should also ensure help desk staff are trained on the new self-service capabilities and understand how password write-back affects their support processes. Device synchronization and hybrid join. Azure AD Connect can synchronize device objects from on-premises Active Directory to Azure Active Directory, enabling hybrid device scenarios that bridge traditional domain-joined computers with cloud-based management and authentication. Device synchronization is a critical component for implementing Windows Hello for Business, seamless single sign-on, and conditional access policies that consider device compliance state. Understanding the device synchronization process and hybrid Azure AD Join functionality is essential for organizations implementing modern endpoint management strategies. Hybrid Azure AD Join allows devices that are joined to on-premises Active Directory to also be registered in Azure Active Directory, creating a hybrid identity for the device. This dual registration enables the device to access both on-premises resources using Kerberos Authentication and cloud resources using Azure AD Authentication, all with a seamless single sign-on experience. When Azure AD Connect synchronizes device objects, it creates computer objects in Azure AD that correspond to domain-joined computers in Active Directory. The synchronization includes device attributes such as the computer name, operating system version, and device identifier, enabling Azure AD to track and manage these devices. The hybrid join process involves several steps coordinated between on-premises and cloud components. When a domain-joined Windows 10 or Windows 11 computer boots up, it queries Active Directory for a service connection point that contains information about the Azure AD tenant. Using this information, the device registers itself with Azure AD using device credentials. Azure AD issues a primary refresh token that is stored on the device and used for subsequent authentication to cloud resources. This registration process happens automatically for domain-joined devices when hybrid join is properly configured, requiring no user interaction. The device then appears in Azure AD with a hybrid join state, indicating it has both on-premises and cloud identities. Configuring hybrid Azure AD Join requires careful planning and execution. The process involves enabling device synchronization in Azure AD Connect, configuring service connection points in Active Directory that point to the Azure AD tenant, and ensuring network connectivity allows devices to reach Azure AD registration endpoints. For Windows 10 and Windows 11 devices, Hybrid Join works automatically through the Windows Device Registration Service. For down-level devices like Windows 7 or Windows 8.1, additional group policy objects must be configured to trigger device registration. Organizations must also consider certificate requirements, as Hybrid Join relies on device certificates for authentication. Once configured, devices automatically register with Azure AD when they authenticate to the domain, and their state can be viewed in the Azure AD portal under the Devices section. Conditional access policies can then leverage device state to enforce access controls based on whether devices are hybrid joined, compliant with management policies, or properly secured. Multi-forest synchronization topology. Many enterprise organizations operate multiple Active Directory forests due to mergers and acquisitions, organizational boundaries, or security requirements. Azure AD Connect supports synchronizing multiple forests to a single Azure AD tenant, enabling unified identity management across complex enterprise environments. Understanding multi-forest topologies and their configuration requirements is essential for implementing Azure AD Connect in these scenarios. The single instance, multiple forests topology is the most common approach for multi-forest synchronization. In this configuration, a single Azure AD Connect server synchronizes objects from multiple on-premises Active Directory forests to one Azure AD tenant. The Azure AD Connect server must have network connectivity to domain controllers in each forest and appropriate read permissions on all objects in scope for synchronization. This topology works well when forests are connected through forest trusts and user objects are unique across forests, meaning no user has accounts in multiple forests. The synchronization engine uses the source anchor attribute, typically object GUID or MS-DS-consistency GUID, to uniquely identify each object across all forests. Account resource forest topologies present additional complexity where user accounts exist in one forest while resources like Exchange mailboxes exist in another forest. In this scenario, users have disabled user accounts in the resource forest that are linked to enabled user accounts in the account forest. Azure AD Connect must be configured to merge these related objects into a single user object in Azure AD. This is accomplished using synchronization rules that match objects based on specific attributes, typically using the MS Exchange Master Account SID attribute to correlate the disabled account with the enabled account. The resulting merged object in Azure AD contains attributes from both the account and resource forests, representing a complete user identity. Full mesh topologies involve multiple Azure AD Connect servers, each synchronizing objects from different forests, with all servers exporting to the same Azure AD tenant. While technically supported, this topology is generally discouraged because it increases complexity and the potential for synchronization conflicts. If multiple servers attempt to manage the same object in Azure AD, conflicts can occur that require manual resolution. Microsoft recommends using staging mode for redundancy instead of active multi-server topologies. In staging mode, a secondary Azure AD Connect server is configured identically to the primary server but operates in staging mode, which means it performs all synchronization operations except exporting to Azure AD if the primary server fails. The staging server can be quickly promoted to active mode to maintain synchronization continuity. Planning multi-forest synchronization requires careful consideration of object deduplication and uniqueness. The GAL-sync approach uses contact objects or mail-enabled users to represent users from other forests, enabling global address list population across forests. When multiple forests contain different user populations, this works well. However, when the same physical users have accounts in multiple forests, Azure AD Connect must be configured to recognize these duplicates and either filter them or merge them appropriately. Custom synchronization rules can implement complex matching logic based on attributes like employee ID, email address, or other unique identifiers. Thorough testing in non-production environments is critical before deploying multi-forest synchronization to production, as mistakes in object matching can result in duplicate or incorrectly merged identities in Azure AD. Disaster recovery and business continuity. Azure AD Connect is a critical component of hybrid identity infrastructure, and its failure can prevent users from accessing cloud resources or cause authentication problems. Implementing proper disaster recovery and business continuity measures ensures that identity synchronization can be quickly restored if the primary Azure AD Connect server experiences hardware failure, corruption, or other catastrophic issues. Understanding disaster recovery options and best practices is essential for maintaining reliable hybrid identity operations. Staging mode provides the foundation for Azure AD Connect disaster recovery. A second Azure AD Connect server is installed and configured identically to the primary server, including the same synchronization rules, filtering settings, and authentication method. However, this secondary server is configured to operate in staging mode, which means it performs all synchronization operations including importing from Active Directory, applying synchronization rules, and staging changes in connector spaces, but it does not export changes to Azure AD. The staging server maintains a current view of what would be synchronized to Azure AD without actually modifying the cloud directory. This configuration allows the staging server to be promoted to active mode very quickly if the primary server fails. The failover process from a failed primary server to a staging server is straightforward but requires careful execution. First, ensure the primary server is truly unavailable and not just experiencing temporary network issues or performance problems. Attempting to run two active Azure AD Connect servers simultaneously will cause synchronization conflicts. Once confirmed that the primary server cannot be recovered quickly, connect to the staging server and run the Azure AD Connect wizard. Select the option to disable staging mode, which requires global administrator credentials for the Azure AD tenant. After confirming the change, the server immediately begins exporting changes to Azure AD and becomes the active synchronization server. The entire failover process typically takes less than 10 minutes, during which synchronization is temporarily paused but user authentication continues normally. Database backup and restore represents another disaster recovery option, particularly for scenarios where the staging server approach is not feasible. Azure AD Connect stores its configuration and synchronization state in a secure query language database, either Secure Query Language Server Express for smaller deployments or Full Secure Query Language Server for larger environments. Regular backups of this database capture the complete Azure AD Connect configuration including synchronization rules, connector settings, and object state information. If the Azure AD Connect server fails, you can install Azure AD Connect on a new server and restore the database backup, recovering the entire configuration without manual reconfiguration. However, this approach requires more recovery time than staging mode promotion and requires ensuring the database backup is current. Documentation and configuration management are often overlooked aspects of disaster recovery planning. Organizations should maintain detailed documentation of their Azure AD Connect configuration including installation parameters, custom synchronization rules, filtering settings, authentication method, and any modifications made to default settings. This documentation enables faster recovery by providing a reference for rebuilding the server if necessary. Configuration files from Azure AD Connect should be backed up, particularly if custom synchronization rules have been created. Some organizations use infrastructure as a service approaches where Azure AD Connect configuration is defined in scripts or configuration management tools, allowing automated deployment of new servers with identical configurations. Regular disaster recovery testing validates that backup procedures work correctly and that staff understand the recovery process, reducing recovery time objectives when actual failures occur. Custom synchronization rules. While Azure AD Connect includes default synchronization rules that work for most scenarios, many organizations require custom rules to address unique business requirements. Custom synchronization rules allow modification of which objects are synchronized, how attributes are transformed, and how objects from different directories are joined. Understanding how to create and manage custom synchronization rules is essential for advanced Azure AD Connect implementations. Synchronization rules in Azure AD Connect consist of several components that work together to control object flow and transformation. The scoping filter determines which objects the rule applies to based on attribute values. For example, a scoping filter might specify that the rule only applies to user objects where the department attribute equals sales. Join rules establish relationships between objects in different connector spaces, typically used in multi-forest scenarios to correlate related objects. Transformation rules define how source attributes map to target attributes and can include direct attribute flows, constant values, or expressions that manipulate attribute values using functions and logic. The precedence value of synchronization rules is critical for determining which rules take effect when multiple rules apply to the same object. Rules are evaluated in order of precedence, with lower numbers having higher priority. Azure AD Connect's default rules use precedence values ranging from 100 to 500, leaving lower values available for custom rules. When creating custom rules, assigning a precedence lower than 100 ensures your custom rule takes priority over default rules. This allows overriding default behavior without modifying the default rules themselves, which is important because default rules are reset when Azure AD Connect is upgraded. Custom rules survive upgrades, maintaining your configuration through version updates. Expression-based attribute transformations provide powerful capabilities for manipulating data during synchronization. The expression language supports string functions like trim, lcase, ucase for string manipulation, IIF for conditional logic, is present to check attribute existence, and mathematical operations. A common example is constructing a user's display name by concatenating multiple attributes. An expression like word join with comma separator and trim can combine first name, middle initial, and last name while handling cases where middle name might be missing. Another common transformation converts an on-premises user principal name to a cloud-compatible format by replacing the domain suffix, necessary when on-premises user principal name suffixes do not match Azure AD verified domains. Creating custom synchronization rules requires using the Synchronization Rules Editor, a tool installed with Azure AD Connect. The editor provides a graphical interface for defining all aspects of synchronization rules including direction inbound or outbound, scope filters, join criteria, and transformation mappings. After creating a custom rule, it must be thoroughly tested to ensure it behaves as expected and does not cause unintended synchronization problems. Testing typically involves running a synchronization preview for specific objects to see how the rule affects them before applying changes to the entire directory. Organizations should maintain documentation of all custom synchronization rules including the business justification, technical implementation details, and testing results. This documentation is invaluable during troubleshooting and for onboarding new administrators who need to understand the Azure AD Connect configuration. Performance optimization strategies. As organizations grow and the number of synchronized objects increases, Azure AD Connect performance becomes increasingly important. Poorly performing synchronization can result in long synchronization cycles, delayed identity updates, and potential timeout issues. Implementing performance optimization strategies ensures that Azure AD Connect scales effectively and maintains reliable operation even in large environments with hundreds of thousands of objects. The synchronization database backend significantly impacts performance. By default, Azure AD Connect installs SQL Server Express Local DB, which is suitable for environments with up to 100,000 objects. For larger environments, migrating to a full SQL Server instance provides substantial performance improvements. Full SQL Server offers better query optimization, more memory allocation, and superior I/O performance compared to SQL Server Express. The database can be hosted on the same server as Azure AD Connect or on a remote SQL Server instance, though local database hosting typically provides better performance due to reduced network latency. When using remote SQL Server, ensure high bandwidth, low latency connectivity between the Azure AD Connect server and database server. Object filtering reduces the synchronization workload by excluding unnecessary objects from synchronization. Many organizations have service accounts, test accounts, disabled user accounts, and other objects in Active Directory that do not need cloud presence. Implementing domain filtering, OU filtering, or attribute-based filtering to exclude these objects reduces the number of objects in the Azure AD Connect database, decreasing synchronization time and improving performance. However, filtering decisions must be made carefully to avoid excluding legitimate user accounts. A phased approach where filtering is initially conservative and then refined based on usage patterns often works well. Attribute selection optimization involves synchronizing only the attributes actually needed by cloud applications rather than all available attributes. Azure AD Connect's default configuration synchronizes a comprehensive set of attributes to support various scenarios, but not all organizations need every attribute. Using the Azure AD Connect Wizard's attribute filtering options, you can deselect optional attributes that are not required, reducing the amount of data transferred during each synchronization cycle. However, be cautious when removing attributes because some cloud applications depend on specific attributes being present. For example, Exchange Online requires certain Exchange-related attributes, while some third-party SaaS applications might expect custom attributes. Documentation from application vendors should be consulted before removing attribute synchronization. Hardware resources directly impact synchronization performance. Azure AD Connect benefits from faster CPU processors for executing synchronization rules and transformations, more RAM for caching database operations, and fast disk input-output for database reads and writes. Solid-state drives provide dramatically better performance than traditional spinning disks, particularly for the SQL database files. Network bandwidth affects communication with domain controllers and Azure AD, though modern networks typically provide sufficient capacity. Monitoring Azure AD Connect performance using Windows Performance Monitor counters helps identify resource bottlenecks. Key counters to monitor include CPU utilization, memory usage, disk queue length, and network throughput. If performance issues are detected, upgrading hardware or adjusting configuration settings based on monitoring data can resolve problems. Regular performance reviews ensure Azure AD Connect continues to meet operational requirements as the environment grows and changes over time. Security best practices. Azure AD Connect has access to sensitive identity information in both on-premises Active Directory and Azure Active Directory, making it a high-value target for attackers. Implementing comprehensive security best practices protects the integrity of your hybrid identity infrastructure and prevents unauthorized access to identity data. Security should be considered at every layer, including server hardening, access control, network security, and monitoring. Server hardening begins with installing Azure AD Connect on a dedicated, well-maintained Windows server. The server should be fully patched with the latest security updates and configured according to security baselines such as the CIS benchmarks. Unnecessary services, roles, and features should be removed to reduce the attack surface. Antivirus and endpoint detection software should be installed and configured to exclude the Azure AD Connect installation directory and SQL database files from real-time scanning, as scanning these files can interfere with synchronization operations. However, scheduled scans should still include these directories to detect potential compromises. The server should be physically secured if it is hosted on premises, with access restricted to authorized personnel only. Access control to the Azure AD Connect server must be tightly restricted. Only authorized identity administrators should have administrative access to the server. The local administrators group should be carefully managed, removing default members and adding only required administrator accounts. The Azure AD Connect service account requires specific permissions in Active Directory but should not be a member of privileged groups like domain admins unless absolutely necessary. Most synchronization scenarios require only read permissions on objects in scope plus write permissions for password writeback if enabled. Following the principle of least privilege when assigning permissions reduces the potential impact if the service account is compromised. Multi-factor authentication should be required for all administrative access to the Azure AD Connect server, whether through remote desktop, PowerShell remoting, or physical console access. Network segmentation provides defense in depth by isolating the Azure AD Connect server from general network traffic. The server should be placed in a secure network segment with firewall rules restricting inbound traffic to only necessary management protocols. Outbound traffic should be filtered to allow only required connections to domain controllers, Azure AD endpoints, and management systems. Using a proxy server for Azure AD Connect's internet connectivity provides additional logging and control over cloud communications. For organizations with multiple Azure AD Connect servers in staging mode configuration, secure communication channels should be established between servers. Certificate-based authentication should be used wherever possible instead of password-based authentication to reduce credential exposure. Monitoring and auditing provide visibility into Azure AD Connect operations and help detect security incidents. Event logging should be configured to capture authentication attempts, configuration changes, synchronization operations, and error conditions. These logs should be forwarded to a centralized security information and event management system where they can be correlated with logs from other systems and analyzed for suspicious patterns. Alerts should be configured for critical events such as synchronization failures, authentication errors, configuration changes, and unauthorized access attempts. Regular security assessments including vulnerability scanning and penetration testing help identify security weaknesses before attackers can exploit them. Azure AD Connect's configuration should be reviewed periodically to ensure it follows current security best practices and that no unauthorized changes have been made. Implementing these comprehensive security measures significantly reduces the risk of identity compromise and ensures the integrity of your hybrid identity infrastructure. Directory extension attributes. Directory extension attributes provide a mechanism for extending the Azure Active Directory schema to store custom attributes that are not part of the standard schema. Many organizations have custom attributes in their on-premises Active Directory that contain business-specific information such as employee IDs, cost centers, division codes, or custom identifiers. Directory extensions allow these custom attributes to be synchronized to Azure AD and made available to cloud applications, enabling consistent identity attributes across hybrid environments. Azure AD Connect supports synchronizing up to 15 directory extension attributes per object class. These extensions are registered in Azure AD using a specific naming format that includes the application ID of the registered application and the attribute name. The registration process creates new attribute definitions in the Azure AD schema that can then be populated with values from on-premises attributes. Once registered, directory extensions behave like standard Azure AD attributes and can be used in conditional access policies, populated in ID tokens and access tokens for applications, and queried using Microsoft Graph API. The configuration process for directory extensions involves several steps. First, you must identify which on-premises attributes need to be extended to Azure AD. These might be standard Active Directory attributes like Extension Attribute 1 through Extension Attribute 15, or custom attributes defined in your Active Directory schema. Second, during Azure AD Connect installation or through the customization wizard, you select these attributes for synchronization and designate them as directory extensions. Azure AD Connect automatically registers the necessary schema extensions in Azure AD. Third, synchronization rules are configured to flow the on-premises attribute values to the corresponding extension attributes in Azure AD. The synchronization engine handles the attribute mapping and ensures values are properly formatted according to Azure AD requirements. Applications can consume directory extension attributes once they are synchronized to Azure AD. Modern authentication protocols like AD Connect and OAuth allow applications to request specific attributes in tokens. By configuring token claims in Azure AD, you can include extension attributes in ID tokens that are issued to applications during user authentication. This enables applications to access custom identity data without requiring separate database lookups or API calls. For example, a line of business application might use an employee ID extension attribute to correlate Azure AD identities with records in an HR database. Microsoft Graph API provides programmatic access to extension attributes, allowing custom applications and scripts to read and write these values. However, it is important to note that directory extensions synchronized from on-premises are typically read only in Azure AD, with updates made in the authoritative on-premises directory and flowed to the cloud through synchronization. Azure AD Connect Cloud Sync Comparison. Microsoft has introduced Azure AD Connect Cloud Sync as an alternative to the traditional Azure AD Connect synchronization solution. While both tools serve the purpose of synchronizing on-premises identities to Azure AD, they differ significantly in architecture, capabilities, and operational models. Understanding these differences helps organizations choose the appropriate solution for their specific requirements and migration strategies. Azure AD Connect Cloud Sync uses a lightweight agent architecture rather than running a full synchronization engine on-premises. The Cloud Sync agent is a small service installed on domain-joined Windows servers that acts as a bridge between on-premises Active Directory and the cloud-based synchronization service running in Azure. The actual synchronization logic, rules processing, and data transformation occur in the Microsoft Cloud rather than on your on-premises infrastructure. This cloud-first architecture reduces the on-premises footprint and shifts operational responsibility to Microsoft's managed service. Multiple agents can be deployed for high availability, and they automatically load balance synchronization operations without requiring complex clustering or failover configurations. Feature differences between Azure AD Connect and Cloud Sync are significant. Azure AD Connect supports comprehensive scenarios including device synchronization, password write-back, group write-back, and integration with a DFS for federation. It provides extensive customization through synchronization rules, supports multiple forests with complex topologies, and offers staging mode for disaster recovery. Cloud Sync, in contrast, focuses on core user and group synchronization with a more limited feature set. It does not support device sync, group write-back, or many advanced customization options. However, Cloud Sync excels in scenarios like managing multiple disconnected Active Directory forests, implementing lightweight synchronization for acquired companies, or providing backup synchronization when migrating from complex Azure AD Connect deployments. The operational model differs substantially between the two solutions. Azure AD Connect requires on-premises infrastructure maintenance including server patching, SQL database management, and monitoring. Administrators must plan and execute upgrades to new versions of Azure AD Connect. With Cloud Sync, Microsoft handles service updates and infrastructure management as part of the cloud service. The agent automatically updates itself, reducing administrative overhead. Troubleshooting also differs, with Azure AD Connect providing local tools like Synchronization Service Manager, while Cloud Sync relies primarily on cloud-based provisioning logs accessible through the Azure portal. Neither approach is universally superior, as the choice depends on organizational requirements, existing infrastructure, and operational preferences. Migration scenarios between Azure AD Connect and Cloud Sync require careful planning. Organizations cannot simply switch from one solution to another without consideration of how object ownership and synchronization scope are managed. Microsoft provides guidance for various migration scenarios, including running both solutions in parallel for different sets of users during transition periods. For new deployments, Evaluating requirements against the feature sets of both solutions helps determine the best fit. Organizations with straightforward synchronization needs, preference for cloud-managed services, and willingness to accept current feature limitations might prefer Cloud Sync. Those requiring advanced features, extensive customization, or full control over synchronization logic should choose traditional Azure AD Connect. As Cloud Sync continues to mature and add features, the decision calculus may shift over time. Group Write-Back Configuration. Group Write-Back is a feature that enables groups created in Azure Active Directory to be written back to on-premises Active Directory, creating a reverse synchronization flow for group objects. This capability is particularly valuable for Office 365 groups and Microsoft Teams because these groups exist primarily in the cloud but may need to be accessible from on-premises applications and directory-aware services. Group Write-Back creates corresponding distribution groups in on-premises Active Directory that contain the membership synchronized from cloud groups. The architecture of Group Write-Back involves the Azure AD Connect synchronization engine monitoring Azure AD for changes to groups that are configured for write-back. When a new Office 365 group or Microsoft 365 group is created in the cloud and marked for write-back, Azure AD Connect creates a corresponding mail-enabled distribution group in the designated organizational unit in on-premises Active Directory. The group's membership is continuously synchronized from Azure AD to the on-premises group, ensuring that changes to group membership in the cloud are reflected on-premises. This allows on-premises applications that query Active Directory for group membership to see current membership that includes both on-premises and cloud-only users who are members of the cloud group. Configuration requirements for Group Write-Back include Azure AD Premium licensing for the feature, proper permissions for the Azure AD Connect service account to create and manage group objects in Active Directory, and designation of a target organizational unit where written-back groups will be created. The organizational unit should be specifically created for this purpose and not contain other group objects, as Azure AD Connect manages all groups in this container. Filtering rules can be applied to control which cloud groups are written back to on-premises, allowing selective write-back rather than synchronizing all cloud groups. The Exchange schema must be present in Active Directory even if Exchange Server is not installed, because written-back groups are created as mail-enabled distribution groups with Exchange attributes. Use cases for Group Write-Back typically involve scenarios where cloud-created groups need to be visible to on-premises resources. For example, an organization using Microsoft Teams for collaboration might have teams that include both on-premises users and cloud-only guest users. If an on-premises application needs to grant permissions based on team membership, Group Write-Back ensures the application can query Active Directory and see the complete team membership. Another common scenario involves Office 365 groups used for email distribution lists where some recipients still use on-premises Exchange mailboxes. Writing these groups back to Active Directory allows on-premises Exchange to expand the group membership and deliver mail to all members. However, organizations should carefully consider whether Group Write-Back is necessary, as it adds complexity to the synchronization environment and requires ongoing management of the written-back group objects in Active Directory. Seamless Single Sign-On implementation. Seamless Single Sign-On is a feature that provides automatic sign-in to Azure AD for users on domain-joined computers connected to the corporate network. When properly configured, users do not need to enter credentials to access cloud applications, as their on-premises domain credentials are seamlessly used for Azure AD Authentication. This feature dramatically improves user experience by eliminating repetitive password prompts while maintaining strong security through integration with existing Kerberos infrastructure. The technical implementation of seamless single sign-on relies on Kerberos protocol and integrated Windows authentication. Azure AD Connect creates a computer account named AZUREADSSOACC in each Active Directory domain that will use seamless single sign-on. This account represents Azure AD in the on-premises domain and has a Kerberos decryption key shared with Azure AD when a user on a domain-joined computer attempts to access an Azure AD integrated application. The application redirects to Azure AD for authentication. Azure AD recognizes that seamless single sign-on is configured for the domain and returns a Kerberos authentication challenge to the browser. The browser, using integrated Windows authentication, requests a Kerberos ticket from the local domain controller for the Azure AD SSOACC service principal. The domain controller issues a Kerberos ticket encrypted with the Azure AD SSOACC accounts key and returns it to the browser, which sends the ticket to Azure AD. Azure AD decrypts the ticket using the shared key, validates the user identity, and issues authentication tokens for the application. Configuration steps for seamless single sign-on begin with enabling the feature through the Azure AD Connect wizard. The wizard prompts for domain administrator credentials for each domain where seamless single sign-on will be enabled, as it needs to create the Azure AD SSOACC computer account with specific permissions. After enabling the feature on Azure AD Connect, client configuration is required to ensure browsers send Kerberos tickets to Azure AD. For domain-joined Windows computers, group policy is used to add specific Azure AD uniform resource locators to the Intranet zone in Internet Explorer and Edge, and to enable automatic logon with integrated authentication. These group policy settings ensure that when users access Azure AD login pages, their browsers automatically attempt Kerberos authentication rather than prompting for credentials. For Mac OS and Linux clients, additional configuration is needed to enable Kerberos authentication in the respective browsers. Security considerations for seamless single sign-on involve protecting the Azure AD SSOACC computer account and understanding the security implications of automatic authentication. The computer account's password should be rolled periodically using PowerShell commandlets provided by Microsoft, with recommended intervals of 30 to 90 days to maintain security hygiene. The account has specific permissions that should not be modified, and its password should never be manually reset, as this would break seamless single sign-on functionality until Azure AD Connect reconfigures the account. From a user perspective, seamless single sign-on works only on corporate network where devices can reach domain controllers for Kerberos authentication. Users working remotely without VPN connectivity will fall back to standard credential prompts, though this can be addressed by combining seamless single sign-on with password hash synchronization or pass-through authentication. Organizations should also be aware that seamless single sign-on requires desktop applications to properly support integrated Windows authentication, though most modern applications and browsers handle this correctly. Upgrade and patch management. Keeping Azure AD Connect up to date with the latest versions and security patches is critical for maintaining a secure and reliable hybrid identity infrastructure. Microsoft regularly releases new versions of Azure AD Connect that include security fixes, bug corrections, and new features. Understanding the upgrade process, planning upgrade activities, and implementing proper testing procedures ensures that updates are applied safely without disrupting identity synchronization. Azure AD Connect supports automatic upgrade for installations that meet specific criteria. Automatic upgrade is a feature that downloads and installs minor updates and patches without administrator intervention, helping ensure servers stay current with security fixes. However, automatic upgrade only applies to installations using SQL Server Express Local DB in default configurations without extensive customization. If automatic upgrade is enabled, the Azure AD Connect service periodically checks for new versions and downloads updates during maintenance windows. The upgrade process is designed to be non-disruptive, but administrators should monitor automatic upgrades through event logs and Azure AD Connect Health to ensure they complete successfully. For installations that do not qualify for automatic upgrade, such as those using remote SQL Server or with complex custom synchronization rules, manual upgrades are required. Manual upgrade procedures involve downloading the latest Azure AD Connect installer from the Microsoft Download Center and running it on the server. The installer detects the existing installation and performs an in-place upgrade, preserving configuration settings and synchronization rules. Before starting an upgrade, best practices include documenting the current configuration, exporting synchronization rules using PowerShell, backing up the SQL database, and ensuring the staging server is updated first in environments with staging mode configurations. The upgrade process typically takes 10 to 30 minutes depending on the number of objects and database size. During the upgrade, synchronization is temporarily paused but resumes automatically when the upgrade completes. Users are not affected by the upgrade process as authentication continues normally even while synchronization is paused. Testing upgrades in non-production environments before applying them to production is a critical risk mitigation strategy. Organizations should maintain a test environment that mirrors the production Azure AD Connect configuration, including similar numbers of objects, the same authentication method, and representative synchronization rules. Upgrades should first be applied to the test environment and thoroughly validated to ensure synchronization works correctly, custom rules still function as expected, and no unexpected behavior is introduced. After successful testing, the upgrade can be applied to the production staging server if one exists, followed by the primary production server. This phased approach minimizes the risk of synchronization disruptions from problematic upgrades. Version lifecycle management is important for long-term planning. Microsoft publishes a support lifecycle for Azure AD Connect versions, eventually deprecating older versions and requiring upgrades to maintain support. Organizations should establish policies for regular upgrade cycles, such as upgrading within 60 days of new version releases for environments with automatic upgrade enabled, or within 90 days for environments requiring manual upgrades. Monitoring Azure AD Connect Health provides visibility into the current version and alerts when versions approach end of support. Staying current with Azure AD Connect versions ensures access to the latest security protections, performance improvements, and feature enhancements while maintaining Microsoft support eligibility. Certificate management for Federation. Organizations using Federation with Active Directory Federation services must manage several types of certificates that are critical for secure authentication and trust relationships. Certificate management is one of the most common sources of authentication failures in federated environments, as expired or misconfigured certificates break the trust chain between on-premises federation infrastructure and Azure Active Directory. Understanding certificate types, renewal procedures, and monitoring approaches prevents authentication outages caused by certificate issues. The token signing certificate is the most critical certificate in a federated environment. This certificate is used by a DFS to digitally sign security tokens issued to users after successful authentication. Azure AD must have the public key of this certificate to verify the signature on tokens it receives from a DFS. When the token signing certificate is renewed or replaced on a DFS servers, the new certificate must be uploaded to Azure AD to update the Federation Trust. By default, ADFS automatically generates self-signed token signing certificates and rotates them annually. While this automation is convenient, it requires coordination with Azure AD Connect or manual updates to Azure AD when certificate rollover occurs. Some organizations prefer using certificates issued by an internal certificate authority or public certificate authority for better control over certificate lifecycle, though this requires manual certificate management. The token decryption certificate is used by a DFS to decrypt authentication requests from Azure AD when Azure AD needs to send confidential information to the Federation service. It encrypts the data using the public key of the token decryption certificate. Only the ADFS servers, which possess the corresponding private key, can decrypt this information. Like the token signing certificate, the token decryption certificate requires periodic renewal. ADFS handles this automatically with self-signed certificates, but the certificate must be configured in Azure AD if using externally issued certificates. The token decryption certificate is less frequently a source of authentication issues compared to the token signing certificate because its expiration does not immediately break authentication, though it can cause problems with specific authentication scenarios. Secure Sockets Layer certificates for HTTPS communication protect traffic to and from Active Directory Federation Services servers and web application proxy servers. These certificates must be issued by a certificate authority trusted by client browsers to avoid security warnings. The certificates must have proper subject names matching the Federation Service fully qualified domain name and any additional names required for authentication endpoints. Secure Sockets Layer certificate renewal is straightforward but critical, as expired Secure Sockets Layer certificates prevent users from accessing the Active Directory Federation Services login pages. Organizations typically use certificates from public certificate authorities for Secure Sockets Layer to ensure trust by all clients, including external users and personal devices. Certificate renewal typically occurs annually, and proper change management processes should track Secure Sockets Layer certificate expiration dates to ensure timely renewal. Certificate monitoring and automation help prevent authentication outages. Azure AD Connect Health for ADFS includes certificate monitoring that alerts administrators when token signing and token decryption certificates are approaching expiration. Custom PowerShell scripts can query ADFS for certificate expiration dates and send notifications when certificates need attention. For environments using ADFS automatic certificate rollover, Azure AD Connect can automatically update the Federation Trust in Azure AD with new certificate information if the automatic rollover feature is enabled. However, administrators should never rely solely on automation and should implement manual verification procedures to confirm certificate updates are properly applied to all components in the Federation infrastructure. Documentation of certificate renewal procedures and maintaining an accurate inventory of all certificates used in the environment ensures smooth certificate lifecycle management. Troubleshooting tools and utilities. Effective troubleshooting of Azure AD Connect issues requires familiarity with various tools and utilities that provide visibility into synchronization operations, configuration settings, and system health. Microsoft provides both graphical and command line tools for diagnosing and resolving problems. Understanding which tools to use for different types of issues and how to interpret their output accelerates problem resolution and minimizes downtime. The Synchronization Service Manager is the primary graphical tool for monitoring and troubleshooting Azure AD Connect. This application provides 4 main tabs that display different aspects of synchronization operations. The Operations tab shows a chronological history of all synchronization runs with detailed statistics for each operation including objects added, updated, deleted, and errors encountered. Clicking on a specific synchronization run reveals detailed information about which connector spaces were processed and whether the run completed successfully or encountered errors. The Connectors tab displays all configured connectors for Active Directory and Azure AD, showing their properties and allowing administrators to run manual synchronization operations. The Metaverse Search tab enables searching for objects in the metaverse to view their attributes and understand how they are projected from connector spaces. The Metaverse Designer tab shows the schema of the metaverse and object type mappings, though this is rarely modified. PowerShell provides comprehensive access to Azure AD Connect functionality through the AD Sync module. This module includes dozens of commandlets for querying and managing synchronization operations. Get AD Sync Scheduler displays the current synchronization schedule configuration including whether the scheduler is enabled and when the next sync cycle will run. Start AD Sync cycle manually triggers a synchronization cycle, useful for testing changes or forcing immediate synchronization after making configuration modifications. The policy type parameter can be set to delta for incremental synchronization or initial for full synchronization. Get AD Sync CS object queries connector space objects, allowing administrators to examine individual objects and their attribute values as they exist in the connector space. This is particularly useful for troubleshooting synchronization errors by comparing connector space object attributes with their source directory values. The Synchronization Rules Editor provides visibility into and the ability to modify synchronization rules. This tool displays all inbound and outbound synchronization rules, showing their precedence, connector, object type, and link type. Administrators can examine individual rules to view scoping filters, join conditions, and attribute flow transformations. The editor enables creating custom synchronization rules and modifying existing custom rules, though Microsoft recommends not editing default rules as they are overridden during upgrades. Instead, creating new rules with lower precedence values that override default behavior is the preferred approach. The preview function in the editor allows testing how rules affect specific objects without actually applying changes, which is invaluable for validating custom rules before deployment. Additional diagnostic tools include the ID Fix tool for identifying and correcting common Active Directory object issues before synchronization, Azure AD Connect Health for cloud-based monitoring and alerting, and various logging mechanisms that capture detailed operational information. Event Viewer contains Azure AD Connect event logs under Applications and Services logs that record synchronization events, errors, and informational messages. Verbose logging can be enabled for detailed troubleshooting, though this should be used sparingly as it generates substantial log data. The AD Sync tracing functionality provides extremely detailed diagnostic information useful for working with Microsoft support on complex issues. Familiarity with these various tools and knowing when to use each one enables efficient troubleshooting of the wide range of issues that can occur in hybrid identity environments. Conditional Access Integration. Azure Active Directory conditional access policies work in conjunction with Azure AD Connect to provide adaptive access control based on user identity, device state, location, and risk signals. While conditional access is primarily a cloud-based feature, integration with Azure AD Connect ensures that on-premises identity attributes and device information are available for policy evaluation. Understanding how Azure AD Connect synchronizes the necessary identity information enables effective implementation of conditional access controls for hybrid environments. User Attribute Synchronization provides the foundation for user-based conditional access policies. Attributes such as group membership, department, location, and custom attributes synchronized by Azure AD Connect can be used in conditional access rules to determine access requirements. For example, a conditional access policy might require multi-factor authentication for users in the finance department when accessing financial applications from outside the corporate LAN. The department attribute must be synchronized from on-premises Active Directory to Azure AD for this policy to evaluate correctly. Similarly, security group membership is frequently used in conditional access policies to scope policies to specific user populations. Azure AD Connect synchronizes group objects and their membership, allowing policies to target groups managed in on-premises Active Directory. Device Compliance State Integration enables conditional access policies that consider whether devices meet security requirements. When devices are hybrid Azure AD joined through Azure AD Connect, their compliance state can be evaluated by conditional access policies. Microsoft Intune or third-party mobile device management solutions determine device compliance based on factors like encryption status, operating system version, installed security updates, and presence of required security software. This compliance information is stored in Azure AD and evaluated when users authenticate from their devices. Conditional access policies can require that devices be marked as compliant before granting access to sensitive resources, ensuring that only properly secured devices can access corporate data even when using cloud applications. Location-based policies use IP address and network location information to adjust access requirements based on where authentication requests originate. While location detection is primarily a cloud-based capability, Azure AD Connect synchronization ensures that user accounts have the correct attributes for evaluating location-based rules. For example, Organizations might configure trusted locations representing corporate office networks where users can access applications without additional authentication challenges, while requiring multi-factor authentication for access from untrusted locations. The combination of synchronized identity information from Azure AD Connect and real-time location detection in Azure AD enables sophisticated adaptive access policies that balance security with user convenience. Risk-based conditional access leverages Azure AD Identity Protection, which analyzes authentication attempts for signs of compromised credentials or unusual behavior. When Azure AD Identity Protection detects risk signals such as sign-ins from anonymous IP addresses, atypical travel patterns, or leaked credentials, it assigns risk levels to user accounts and sign-in attempts. Conditional access policies can use these risk levels to enforce additional security measures like requiring multi-factor authentication, forcing password changes, or blocking access entirely. For accounts synchronized from on-premises Active Directory, password hash synchronization enables leaked credential detection, where Azure AD compares synchronized password hashes against databases of compromised credentials. This integration between on-premises identity, Azure AD Connect synchronization, and cloud-based risk detection provides comprehensive protection against identity compromise in hybrid environments. Compliance and auditing capabilities. Organizations subject to regulatory compliance requirements must maintain detailed audit trails of identity management operations and demonstrate proper controls over user access and data protection. Azure AD Connect plays a role in compliance postures by providing logging, reporting, and audit capabilities that document synchronization activities, configuration changes, and access to identity data. Understanding the compliance features available through Azure AD Connect and related Azure AD capabilities helps organizations meet regulatory obligations. Synchronization audit logs capture detailed information about every object synchronized between on-premises Active Directory and Azure Active Directory. These logs record which objects were created, modified, or deleted in Azure AD as a result of synchronization operations. Each audit entry includes timestamps, object identifiers, attributes that changed, and the previous and new values for modified attributes. Azure AD audit logs can be accessed through the Azure portal, exported for archival purposes, or streamed to Azure Monitor, Security Information and Event Management Systems, or Azure Event Hubs for real-time processing. For compliance purposes, organizations typically implement automated export of audit logs to long-term storage systems where they can be retained according to data retention policies and retrieved for compliance audits or forensic investigations. Configuration change tracking documents modifications to Azure AD Connect settings, synchronization rules, filtering configurations, and feature enablement. These configuration changes are recorded in local event logs on the Azure AD Connect server and can be captured by centralized logging systems. For federated environments using a DFS, configuration changes to federation settings are also logged. Maintaining a comprehensive audit trail of configuration changes demonstrates proper change management processes and provides accountability for identity infrastructure modifications. Organizations should implement processes requiring documented approval for configuration changes and technical reviews to ensure changes align with security policies and compliance requirements. Access reviews for synchronized accounts help ensure that user access remains appropriate over time. Azure AD Access Reviews enable periodic reviews of group membership and application access, with reviewers typically being managers or resource owners who can attest to whether users still require access. For accounts synchronized from on-premises Active Directory, access reviews help identify stale accounts that should be disabled or removed from groups granting access to sensitive resources. The combination of automated synchronization through Azure AD Connect and manual access review processes provides both operational efficiency and compliance-required human oversight of access decisions. Review results can be configured to automatically remove access for users who are not approved during reviews, though many organizations prefer manual remediation to maintain control over access changes. Data residency and sovereignty considerations affect how Azure AD Connect is deployed and configured in multinational organizations. Azure AD tenant data is stored in Microsoft data centers in specific geographic regions based on the country selected during tenant creation. Understanding where identity data resides and ensuring compliance with data localization laws is critical for organizations operating in jurisdictions with strict data protection regulations like the General Data Protection Regulation in Europe or data sovereignty requirements in certain countries. While Azure AD Connect synchronizes identity information to Azure AD in the cloud, the data transmission is encrypted and stored in compliance with Microsoft's data protection commitments. Organizations should review Microsoft's data protection documentation, compliance certifications, and data processing agreements to ensure alignment with their specific regulatory requirements. For highly sensitive scenarios, some organizations implement custom synchronization rules to exclude specific attributes from synchronization, keeping certain data exclusively on premises to meet data residency requirements. Future of hybrid identity and migration planning. The landscape of hybrid identity continues to evolve as organizations increasingly adopt cloud-first strategies and Microsoft invests in cloud-native identity solutions. Understanding the strategic direction of hybrid identity technologies helps organizations plan their identity architecture investments and prepare for future migrations. While Azure AD Connect remains the primary synchronization solution for most organizations today, the emergence of Azure AD Connect Cloud Sync and the gradual expansion of native Azure AD capabilities signal a shift toward cloud-managed identity infrastructure. Microsoft's strategic direction emphasizes reducing on-premises infrastructure dependencies and moving identity management functions to the cloud. Azure AD Connect Cloud Sync represents this cloud-first approach with its lightweight agent model and cloud-hosted synchronization engine. As Cloud Sync matures and adds features currently exclusive to Azure AD Connect, Microsoft may eventually position it as the preferred synchronization solution for new deployments. Organizations planning long-term identity strategies should evaluate both solutions and consider how their requirements align with the evolving capabilities. For greenfield deployments or organizations with simple synchronization needs, starting with Cloud Sync may provide a more future-proof foundation. Established environments with complex Azure AD Connect configurations should monitor Cloud Sync feature development and plan eventual migration as capabilities become available. The increasing adoption of passwordless authentication reduces dependency on password synchronization, one of Azure AD Connect's core functions. Technologies like Windows Hello for Business, FIDO2 security keys, and certificate-based authentication eliminate passwords from the authentication process, reducing the need for password hash synchronization. As organizations transition to passwordless authentication, the value proposition for some Azure AD Connect authentication methods shifts. However, passwordless adoption takes time and may never achieve complete coverage across all user populations and applications. Hybrid identity infrastructure will remain necessary for the foreseeable future to support legacy applications, gradual migration timelines, and organizations that maintain on-premises Active Directory for non-authentication purposes like group policy management and computer management. Migration planning from on-premises identity infrastructure to cloud-only identity involves careful phasing and risk mitigation. Organizations pursuing cloud-only identity must consider dependencies on on-premises Active Directory beyond user authentication, including computer domain join, group policies, LDAP directory access by applications, and certificate services. Alternatives exist for many of these functions through Azure AD joined devices, Intune mobile device management, modern application authentication, and cloud-based certificate services, but transitioning requires application modernization and process changes. A phased approach typically begins with migrating user authentication to Azure AD while maintaining device and application dependencies on Active Directory, followed by gradual migration of device management to cloud-based solutions, and finally decommissioning on-premises Active Directory if all dependencies are eliminated. Long-term architectural considerations should account for the possibility that some on-premises infrastructure will remain indefinitely, creating a sustained hybrid identity model rather than complete cloud migration. Many large enterprises have invested substantially in Active Directory and have deep integration with numerous systems. Complete migration may be technically possible but economically unjustifiable compared to maintaining hybrid infrastructure. For these organizations, Azure AD Connect will remain a critical component connecting on-premises and cloud identity systems. Investments in robust Azure AD Connect deployment with high availability, disaster recovery, and proper operational processes provide value over extended timeframes. Regardless of whether cloud-only identity is the ultimate goal or hybrid identity is a permanent state, implementing Azure AD Connect properly according to best practices documented in this presentation ensures reliable, secure, and efficient hybrid identity operations that meet business needs and support organizational objectives. Thank you for your attendance. Please consider subscribing to the channel and liking this video.